Very good evening to all respected members. I warmly welcome all the participants to this workshop on fundamentals of drone technology. Today we will explore the fascinating world of unmanned aerial vehicles, commonly known as drones. This workshop is designed to provide a comprehensive understanding of drone systems, their components, flight principles, navigation technologies, communication systems, basic applications, safety regulations, and future trends. It's my immense pleasure to guide you through this exciting learning journey. Let us follow the today's workshop agenda. In today's segment, we will begin with an introduction to drones and their historical evolution. Next, we will study the basic core components that make up a drone system. We will then examine the principles of flight and aerodynamics that allow drones to fly safely and efficiently. After that, we will discuss the basic navigation and control systems, communication technologies, real world applications, safety regulations, and future developments in drone technology. Finally, we will conclude with few simulation hands on workshop activities and the following key takeaways. So, what exactly meant by a drone? A drone is said to be an unmanned aerial vehicle. Is an aircraft that operates without a pilot on board. It can be remotely controlled or fly autonomously using advanced software applications and sensors. The history of drones date back to the early 19th century when unmanned aerial devices were first used for military operations. Over time, drones evolved from surveillance platforms to powerful tools used in agricultural purpose, geographic mapping, logistics, photography, and many other industries. The major categories of drone include fixed wing aircraft, multi rotor drones, single rotor helicopters, and hybrid vertical takeoff and landing systems. Under this classification, we need to select the right platform according to the specific applications. Now let us see the following core components that forms a drone system. Every drone comprises of several essential components working together. The frame provides structural support and determines the payload capacity. Brushless motors generate rotational force, while electronic speed controller regulate motor speed. The power system, usually based on lithium polymer batteries, supplies energy to the entire drone. The flight controller acts as the brain of the system, processing sensor data and maintaining stability. GPS modules enable navigation and autonomous missions. Finally, mission-specific payloads such as cameras, lidar units, or thermal sensors allow drones to perform highly specialized tasks. Let us now understand the basic flight principles and aerodynamics. For a drone to fly successfully, there are four primary forces must be understood: thrust, lift, drag, and weight. Thrust is being produced by the propellers and must exceed the weight of the drone for takeoff. Lift force is generated through aerodynamic principles and keeps the drone airborne. Drag force opposes motion and must be minimized for efficient flight. Weight represents the gravitational force acting downward. The common drone movement is controlled by rolling, pitching, yaw, and throttle. These four control inputs enable the drone to move in any direction by maintaining its own stability. Now let us Move on to the common navigation control systems. Modern drones heavily rely on sophisticated navigation systems. The inertial measurement unit combines accelerometers and gyroscopes to measure the motion and orientation. GPS receivers provide accurate positioning information. Barometers assist in altitude control, while magnetometers determine the heading direction. Additional sensors such as optical flow cameras, ultrasonic sensors, and lidar sensor improve the stability and obstacle avoidance. Flight controllers such as Adropilot, PX4, Betaflight, and DJI systems process all sensor inputs and execute the control commands using PID algorithms. Different flight modes allow varying levels of automation from manual operation to fully integrated autonomous waypoint missions. Now let us understand the basic communication systems incorporated in the drone technology. Reliable communication is highly essential for safe drone operations. The radio transmitter and receiver establish the primary control link between the pilot and the drone. Telemetry systems provide real-time information including battery status, position, speed, and altitude. First-person view systems transmit live video from onboard cameras, allowing immersive piloting experiences. With advancement of cellular technology such as 4G and 5G, drones can now perform beyond the visual line of sight operations and support cloud-based fleet management. Here are some of the common widespread applications of drone technology as listed below. Drone technology has transformed several numerous industries today. In agriculture, drone assist with crop monitoring, spraying, and yield assessment. In aerial photography and filmmaking, they provide stunning perspectives and efficient data collection. Defense and security sectors use drones for surveillance missions. Surveying and mapping professionals employ drones to create accurate geographical geographic models. Infrastructure inspections are conducted safely using drones equipped with cameras and thermal sensors. Additionally, drones are increasingly being used for package delivery, emergency response, and medical supply transportation. Now let us understand the common regulations, safety, and best practices to be adapted in drone technology. Responsible drone operation requires adherence to regulation and safety standards. In India, drone operations are governed by Drone Rules 2021 under the Directorate General of Civil Aviation. Operators must register eligible drones, follow digital sky requirements, and obtain necessary certification. Before every flight, pilots should inspect batteries, propellers, GPS connectivity, and system calibration. Maintaining visual line of sight, avoiding restricted zones, monitoring weather conditions, and keeping flight logs are essential best practices for safe and compliant operations. Let us see some of the future trends in drone technology. The future of drone technology is extremely promising. Artificial intelligence and machine learning are enabling autonomous decision making and intelligent navigation. Swarm technology allows multiple drones to coordinate complex missions. Urban air mobility concepts are paving the way for passenger drones and air taxis. Advanced sensing technologies such as hyperspectral imaging and lidar continue to expand drone capabilities. The integration of 5G networks and edge computing supports real-time communication and analytics. Meanwhile, solar powered and hybrid energy drones are extending flight endurance for long duration missions. Now let us see some of the hands-on workshop activities. During the practical session, participants will gain valuable hands-on experience. First thing, you will assemble a quadcopter using industry standard components. Firmware installation and calibration procedures will be demonstrated. Flight simulation exercise will help to develop piloting skills in a safe environment. Participants will also learn how to configure the payloads, plan aerial missions, collect data, and process the image using modern drone software tools. These activities try to bridge the gap between the theory and practical implementation. As a part of hands-on workshop activity today, we now take one exercise through simulation module. So configuring the payload of a drone simulator. So you are now watching the simulation window of a drone payload simulator. So let us first understand the term. What is exactly a payload? In short, payload is nothing but an extra weight that is added to the drone system, which is subject to carry during the time of takeoff. It is usually counted outside of the weight of the drone itself and includes anything additional to the drone, such as extra cameras, sensors, or packages for delivery. So, in this simulation exercise, the main objective is to measure the operational efficiency of the drone and the stability of the drone when it is in air under flying mode. To test that, the payload drone simulator can be done in a less expensive manner without using the final prototype model. So for that, I have shown you the drone payload simulator. Now we will continue with the PPT presentation. So before moving on from the today's workshop, let us review the following key takeaways followed by the simulation exercise. You have learned about the basic drone classification, different hardware components, basic flight principles, navigation systems, communication technologies, general application of drone, safety regulation and best practice as well as future developments. I personally encourage you to continue exploring a lot of open source drone platforms, build practical projects, and pursue professional certification opportunities in this rapidly growing field. At the outset, I thank you all the members for your active participation and involvement shown in attending the today's workshop. I wish you great success in your journey into the exciting world of drone technology. Thank you all.